Hello again, everyone. We're going to be doing more solving linear equations algebraically, but this time our learning target is we're going to be solving equations and we're going to be identifying the number of solutions that the equation have. And those solutions are either going to be one solution, no solutions, or infinite solutions. So if we look at this example here, we can critique the reasoning of these three students, Michaela, Ryan, and Gabriella. As you can see, they solve their equations by following these steps. They all have their balance sign, but what I want you to notice is their solutions to their equations. These are the three different types of solution sets that there could be. Michaela, notice she has 5 is equal to negative 35. This is actually an equation that has no solution. Go ahead and write that on your paper. No solution. We can remember this because we all know that 5 does not equal negative 35. This is the does not equal sign here. You can go ahead and put a little slash around that. It does not equal to. Ryan's solution is what we've been typically seeing here. This solution has one solution. The only solution to this equation is 3/2. That is the only value for x that will make both the left and the right side of the equation equal to each other. In Gabriella's equation, she solved, and notice that she has negative 4 is equal to negative 4. Whenever you have an equation that ends up being equal to each other, this means that there are infinite number of solutions, which means there are any number that you plug in for that variable, it is always going to be equal to each other. There are infinite number of solutions, so it doesn't matter if you plug in negative 100 or positive 100 or 0 or a decimal. Anything you plug into x is going to make both sides of those equation balance. These are the three types of solution sets we have we're going to be looking at today. Remember that you can press pause at any time if I'm going too fast or you need to catch up with your notes. Make sure that you have all of this written down onto your paper right now. You shouldn't need a calculator for this lesson today, but if you want to grab one, you can, or you can use one on your computer if you need to. So let's jump into this first example here. For this first example, you can see that the set of numbers 0, 2, and 6 are the possible solutions for these three equations shown. I'm going to do the first two equations. So the first equation, if we plug in 0 into here, 7 times 0 is 0. Negative 10, so it's negative 10 is equal to, let's see, 3 times, if I plug in 0 in for x there, that's 0 again, so negative 10 is equal to 14. Well, that's not true, so we know 0 can't be the correct answer. If we go through and we try to plug in 2 in for x, so 7 times 2, that's 14. 14 minus 10, that is 4. So is 4 going to be equal to, let's see, we plug in 2 here, that's 6. 6 plus 14, no, that's not equal, so 2 can't be a solution set either. Let's see, maybe 6 can be the solution set. So 7 times 6, if we plug in 6 here, let's see, 42, so 42 minus 10 is 32. 32 is equal to, let's see, if we go ahead and plug in 6 into here, so that's 18. 18 plus 14, what is 18 plus 14? Do we need a calculator for that, or we have to go ahead and do the work for it? So 18 plus 14 is going to be 32. So we know, now I'm going to go ahead and circle this, and I want you to circle it as well, that 6 is the solution set to that as well, to that solution. So only 6 is going to work for that. 6 is only going to be the only one solution to this. For the second one, if we plug in these three numbers into x, let's see what happens. So plug in 0 into here. If we plug 0 into here, we get, let's see, 0, so 2, and so 2 is equal to 2, so 0 could be a solution, because 2 is equal to 2, so that works. Let's see, let's try if we plug in 2 into the solution set. So if we plug in 2 here, and we do 4 times 2, which equals 8, so 8 plus 2 is 10. If we plug in 2 here, 8 plus 2, 10 equals 10. So that one is also true as well. So 2 could also be a solution set to this as well. So there's more than one solution here. I bet you 6 is also a solution to this equation. If we plug in 6, so it's 4 times 6 now. 4 times 6 is 24. So 24 plus 2, that's 26. 26 is equal to the other side. We plug in 6 here. It's going to be the same thing. So 6 is also a solution set. This would be one that has many different solutions. It has infinite number of solutions usually. Go ahead and try number 3 on your own. Plug in these 3 values into x and see which, if any, of these solutions can balance the two sides of the equation. Press pause and take a minute. Okay, let's go to the back side. So on the back side, I'm going to do 1a, and then I'm going to have you pause and do 1b on your own. So for 1a, we're going to try to solve this equation just like we normally would. Notice we have x on both sides. You always want to only get x on one side of the equation. So the first thing we're going to do is get rid of those variables on both sides. And what you'll notice pretty quickly is that we'll have 5 is equal to 6. But hold on, 5 is not equal to 6. And going back to our last example, or example at the beginning, whenever we have an equation that is not equal, that's not true, like that first one there, then that means that there are no solutions. There are no solutions to this equation here because that is not true. 5 does not equal to 6. So this is how many solutions does this equation have? None. There are none. Press pause and try 1b on your own. For number 2a, let's solve this one again. So 2a, we're going to try to get x by itself. We're going to try to get x by itself here for 2a. And what you'll notice is we're going to have, let's see here, x minus, we got to combine like terms, so it's going to be negative 2x is equal to 14 minus 4x. Okay, let's get the x on only one side. So I'm going to add 4x to this. I'm going to add 4x here. So then our new equation should be, let's see, 2x is equal to 14. Oh, here we go. If we divide both sides by 2, we should get x. I ran out of room there. X is equal to 7. This is the only solution to this equation when you plug in x into there. If you plug in 7 in for x, there's only one solution. 7 is the only solution to this equation. Press pause and try 2b on your own. For number 3, we're going to solve this equation for x. So we're first going to distribute. When we distribute, we're going to distribute to both sides. So for the left side, let's see, 4 times 2x, that would be 8x, and then 4 times 4 plus 16. That's going to be equal to, the other side we have 8x, so we do 2 times 4x, and then 2 times 8, here, plus 16 as well. Right here you can already notice that these two sides are equal. 8x plus 16 is equal to 8x plus 16. If we want to keep going just to be sure, you can. So let's say we want to get rid of the variables on both sides. I'll subtract 8x to the left, subtract 8x to the right. And what you'll notice is that we're going to end up getting 16 equals to 16. Whenever you're left with a solution like this where it is equal to itself, that means there are infinite number of solutions. Any number that we plug in for x is going to be a solution to this variable. It's going to make both sides of the variable equal. Press pause and try 3b on your own. For number 4, we're going to distribute on the left side. So when you notice when we distribute, we'll get a new equation here because it's going to be 4 times negative 8x, which will give you negative 32x. And then 4 times positive 5 would be plus 20. And then we'll just leave the other side of the equation as it is because there's no like terms we can combine. Now, we're going to go ahead and solve this as much as we can. So let's get rid of our variables on both sides here. I'll add 32x to this side. Do the same thing on the other side. We're going to add 32x to to the other side. And so what we're going to be left with then is 20 is equal to negative 26. Now we know that is not true, so therefore there are no solutions to this equation. No matter what number we plug in for x, we cannot balance both sides of this equation. There is no solution to this equation. Press pause and finally try 4b on your own, and then you are done.